Hello guys, welcome back to the channel Understanding Concepts of Physics. In case you haven't subscribed the channel yet, just please go ahead and subscribe the channel. Today we are continuing with kinetic theory of gases and we'll be finishing two more numericals today, and those two numericals will be based on Stefan Boltzmann's law. So Stefan's Boltzmann's law, and the Stefan Boltzmann's law is basically emissive power of a black body is directly proportional to the fourth power of absolute temperature, and if in order to remove this proportionality sign we multiply by a constant sigma t raised to 4. Sigma is Stefan's law, and this value is 5.67 10 raised to minus 8 joules per meter square second Kelvin raised to 4. So this is the law on which our today's problems will be based. Let's see. So this is one numerical which is pretty easy, and let's see how it works. You can pause the video and go through the question. Calculate the energy. So basically we are supposed to find out energy in 1 minute. So this is one data, 1 minute, and the surface area, that is 100 centimeters square, that is the another data, and maintain at 227 degrees Celsius. That means the temperature is given. So this, let's see. So time is 1 minute. This data I have written in a given form. So time is 1 minute. Minute is not an SI unit, so that converts to second. So 1 minute is 60 seconds. Area is given as 100 centimeters square. Now I'll have to convert this centimeter square to meter square. So 1 centimeter is 10 raised to minus 2 meters. So if I square both the sides, I'll get 1 centimeter square is equal to 10 raised to minus 4 meters square. What I've done is I've just squared it. So because of that, this is the multiplying factor. We need to convert from centimeters to meter square. 10 raised to minus 4 meter square. Because 100 is 10 raised to plus 2, 100 is 10 raised to plus 2, and this is 10 raised to minus 4. So 4 minus 2 is minus 2. So I'll get 10 raised to minus 2 meters square. Temperature should always be in Kelvin, so 227 degrees Celsius plus 273 will give me 500 Kelvin. So this was the given data. They have asked us how much amount of heat energy it is going to emit. So by Stefan's law, EB is equal to sigma T raised to 4, where EB is the emissive power of a perfectly black body, and that is given as amount of heat energy emitted per unit area per unit time, which is equal to sigma T raised to 4. Then I want Q, so I'll take this A and T on the other side. So this A and T will go on the other side, A T sigma T raised to 4. Now put the values of A, T, sigma, T raised to 4. So A is 10 raised to minus 2, time is 60 seconds, sigma is 5.67, 10 raised to minus 8, temperature is 500 raised to 4. If you solve this part, then you get for 2165.25 joules. So solving, again I am not considering that solving is a problem. In case if you are having problem in solving, then do let me know in comments. I will make sure that I'll make sure that you understand how to solve the problem as well. So this is 2165, and that should be in joules. So this is one of the numericals, and let's go to the next numerical, and this numerical is again based on Stefan Boltzmann's law. You can pause the video and go through the question. A lot of data is given. Energy emitted by a hole in an electrical furnace, and the rate is 20 watt. Now because it is watt, it has to be power, and power is nothing but energy upon time. So that's power when the temperature of the furnace is 727. So one data is 20 watt, the other data is 727. And then they have given Stefan's constant. So there are 3 data given, and the 4th data is we are supposed to find out, that is the area. So let's go ahead. So I have written in a tabular form, power, which is energy upon time, is equal to 20 watt. Now watt being an SI system, I will not touch this. Regarding temperature, temperature is 727, that has to be converted to Kelvin. So 727 plus 273 will give me 1000 kelvins. And sigma is given as 5.7. Actual value is 5.67, but make sure that you use the values which are given in a numerical. So you get 5.7 10 raised to minus 8 joules per meter square second Kelvin raised to 4. And you're supposed to find out the area. So I'm again applying the Stefan's law. EB is equal to sigma T raised to 4. EB is the emissive power. This is the emissive power of a perfectly black body, which is Q upon AT, equal to sigma T raised to 4. Now I'm supposed to find out A. So you can just move this A on the other side. So you would get something like this. A equal to Q upon T sigma T raised to 4. So just moving this A on the other side and just moving this sigma and this T raised to 4 on the other side, you land up with this equation. So that's what I have written over here. Just I have made the A on the left hand side and this rest of the part on the right hand side. So what I get is A is equal to Q upon T sigma T raised to 4. Now here the power value is given. That means this Q by T value is 20. So Q by T value is 20. Sigma is 5.7 10 raised to minus 8. And T is 1000 raised to 4. And yes, definitely had this 5.7 been in the numerator, we would have could have done it much more easier, but in case but you should not fear for numbers. Like numbers can be anything, calculations can be anyway, you should be able to solve it. So again, if you are not able to solve this, let me know in the comments and I will do the elaboration. So if you solve this, you get 3.509 10 raised to minus 4 meters square. So that's the amount of area of that particular furnace, that hole of the furnace. So okay, so this is the two numericals which we have done today. In case you haven't subscribed it yet, please do subscribe the channel and keep following the videos. Any of the part if you are not following, I would request you to go back to the previous videos, connecting videos, and I'm sure you will follow the rest. Thank you so much for watching. Bye.